Welcome, everyone. This is a follow-up webinar to the Exploring Elementary Mathematics with Calculator Technology, particularly with the FX55. We hope you joined us for the workshop, but if not, we will cover everything we went over during the workshop, except for the audience participation, of course. But you can always pause it and do it together with your group or your class as we go. My name is Jennifer North Morris. I'm currently serving as on the Casio Teacher Advisory Board, and I've also been a teacher for 11 years in Southern California, and now I'm basically a math coach and get to go in the classrooms and do activities and work on assessment with teachers, and really my focus is how to get kids to explore mathematics and really develop that conceptual understanding of what's going on. We don't want our kids just to generate answers. So with that in mind, let's continue with the workshop, and we will use this calculator, the FX55 you can see here on my screen, as an exploration tool. So I have an assistant online who's going to play a game with me. Hello, Nathan. Are you there?
I'm here, Jen.
Okay.
I'm ready.
So this is Nathan, and he is going to play a game called First to 50 with me. And basically, you have three options. The first player can pick 1, 2, or 3, the numbers 1, 2, or 3, and enter it in the calculator. So Nathan, we'll let you go first. Would you like 1, 2, or 3?
2.
Okay. So 2, and notice I didn't tell him what we're supposed to do. So we're going to enter 2 in the calculator, and now I'm the second player, and I get to either add 1, 2, or 3. So let's say, for example, I'm going to add 3. So that's basically how the game starts. And the goal is we're going to continue going back and forth, adding 1, 2, or 3. The first student who displays 50 on the calculator wins. Okay, you got that, Nathan?
Yep.
Oh, let's ignore those. Okay, so actually, if you can excuse me for a second, let me turn that off. There we go. Okay, so what number do you want, Nathan?
1.
Okay, we're going to add 1. And then I'll add 3 again. Okay.
I'll add 1 again.
I'll add 1. All right, and then I'll add 3.
And 1.
Okay, we're both not being very creative. I'll add 3.
Well, then I'll be 2.
Okay, you're going to add 2 now. Okay. I'll add 2 just to be different. Okay.
3.
Okay, so we're going to add 3. I'll add 3 again. Okay, so we're getting to 50. Okay.
3 again.
3 again. I'll add 1 just to switch it up. Okay.
And 3.
All right. I'm going to add 3.
And 3.
And 3. Okay. We're at 40. Oh, it's my turn. I'm going to add 3.
Now I gotta think.
We're getting close to 50. And depending on the age level that you're working with, the kids might just blaze on through, but if they started to think about it, they may pause.
I'll add 3.
All right. I will add 1.
And I'll add 3.
And he'll add 3. Nathan, congratulations. You won. You
Yes.
got to 50. Thank you very much, Nathan. You can mute yourself again if you want.
Alrighty.
Thank you. So first to 50, I usually have our students play this. And this can be from your first grade kids. You could even do it in kindergarten all the way up to high school. I've done this in high school, and the kids love it. So what you start to think about is you think about, okay, what's going on? Is there a strategy involved? Does it matter who goes first? Does it matter how long you add 3? So we really have the kids play this several times, switch back and forth, whoever goes first, and then figure out what is the strategy? What's going on? And so my question to teachers usually is, what is the mathematics involved? How does the use of technology really help here? So the mathematics, if you think about this, the kids really are adding in their head. So they're trying to predict where they're going, and they're actually thinking in the long run. What's going on in the long run? Okay, where do I have to get? And if you both notice, when I got to 46, I knew I was done. There was no way I was going to be able to win. And so is there a number? Is it always 46? Is there a lower number that you know that you'll win or you'll lose? And then the use of technology here. We're not really using this calculator as just an answer getter. It is giving us answers. However, we have some logical thinking going and getting involved here. So it's not just a way to get the answer. So this is fun. There's other ways to do it. You could do multiplying to 100. Who can get to 100? Who could do that sort of thing? I'm going to get rid of my email. It keeps singing in here. All right, so first to 50, play with alterations. You can start at 10. What if we start at 10? How would that change? So one example of a fun activity you can do where kids can explore the math. Before we go on, of course, for those of you in states that are with the Common Core for mathematics, one of the most important changes with Common Core is the addition of the mathematical practices. I think looking at those, make sense of problems and persevere in solving them, really involving this critical thinking involved, in the mathematics. And so when developing activities for this calculator, we really at Casio keep in mind these mathematical practices. If we aren't using one of these mathematical practices, maybe it's not a good use of the calculator. So keep those in mind as we're going through. And specifically number 5. Number 5, notice, says use appropriate tools strategically, not just use tools, appropriate tools, and use them strategically. So it's very specific about how we're supposed to use this. We're not going to use a calculator just to find the answers, just to check our work. We need to use it strategically to figure out how we can explore and develop that conceptual understanding. And a quote from the Common Core Initiative says that mathematically, proficient students consider available tools when solving a mathematical problem. These tools might include paper and pencil, a calculator. They go on to list several things. And so this is a tool that can be used to really encourage that mathematically proficient student. And then if one of the standards, if you look at number and quantity, the content standard, it specifically states calculators, spreadsheets, and computer algebra systems can provide ways for students to become better acquainted with these new number systems and their notation. So they're even stressing that, yes, a calculator and a graphing calculator can be used efficiently in the classroom to really help that growth. So if you have parents who are really against this idea, or other teachers, colleagues who are against using the calculator, you can share that in the Common Core State Standards Initiative. They really encourage it if it is used strategically. So just remember that. Okay, so let's go to another activity that I love with this calculator is using random numbers. And if we go through, there's several different things we can do with random numbers. But first, what I want to do is let's set up your calculator. And you can go back and do this. If in your class, if you've been using the calculators in the period before, if you're in middle school, you might want to reset the calculators every time. If you've been using them in your classroom and you know they're reset, you don't really have to do this every time. So this is just, I just want to get everybody on the same page with your calculator. So in your calculator, if we press clear, which is this yellow button here, and we'll go to this menu, and you can clear the setup or the memory, but I want to clear everything. And so right here it says 3 all, so we're going to press 3. And it says, are you sure? Cassie's always very careful about that. Are you sure you want to do this? And yes is the equal sign, so we just press the equal sign. If you weren't sure, you can press AC for cancel, but I'm sure here. Okay, so it says, yes, we reset it all, and press the AC key, signifying that you're finished. So I'm going to do that. And then also, so we're on the same page, and in order to do these random numbers that we are going to do, I want to press setup, and we'll visit this again. And I want to choose line. Right now, my calculator may be in math, the math mode, but I want to be in the line mode or the linear mode. So just press 2. And then we're all on the same, our calculators are all set up the same. Okay, so the first thing I'd like you to do is press the random number button, which is this purple one right here, right below the setup, and random number, and then just press equals. So here we could talk about to the kids, okay, what is that number? It's important for them to be able to read this number. What else? Did you get the same as your neighbor? No, why didn't you get the same? Talk about random number. What are random numbers? It's not just magically appearing. And you could press a few different times. Okay. So, but now, especially if you're talking about decimals, if you've got decimal numbers and talk about place value, what is the relationship between these? And so if you're with your students or a bunch of teachers, what I'd like you to do is take your calculator, and everybody, you can clear it out. So let's press clear AC. And now let's get a random number. So press random number and press equals. And now that's your random number. And in the room, I will just point to an area saying that's 0. Oh yeah, before we should probably talk about what's the smallest number, what's the biggest number. So you can talk about that in your class. What is the smallest number? The smallest number would be anything a little greater than 0. So 0, nobody's going to get 0. And then nobody's going to get 1. So we have 0 on one side of the room, 1 on the other side of the room. And you can't see this, but I'm actually directing the computer where to go. It's pretty hilarious. So I'll stop. So I would like you to line up in order, numerical order, between 0 and 1. So you have everyone take their calculators and move over and talk to their neighbors to make sure they're in the right spot. So they'll line up, and then what I do is check your neighbors, make sure everybody's good, and then have the students actually read the number. 196 thousandths is mine. And so they go through and do that. And if you have more time, have them generate another random number. But this time, switch it around so 0's on the other side of the room and 1's on the original side of the room. So switch it around so they really have to move around and think about it. What's that order? And have them line up again. And so this is an activity to really get them thinking about that number sets. Where am I? Where is this number in relationship to everything else? So that's line up. And so I asked the kids, and actually teachers too, what if I don't want a decimal? What if I want it to be some kind of number? How could I change this? Well, if we want a whole number, and actually I would have you guys think about it in your group. If you want a whole number, if you take 1,000 and multiply it by that random number, now keep pressing equals. It will always give you that whole number. And sometime we'll get a 2-digit somewhere in there, and sometimes you'll get, oh, there was a 2-digit. And so basically what it's taking is it's taking that 1,000 and multiplying it by a random number, which is always a 3-place decimal. And now you can have whole numbers. So you could do the same thing. What would happen if we just multiply by 100? What would that be? So you could talk to the kids. Oh, well, it would probably have 1 decimal point. Well, not that one. Oh, that one does. Okay, so you can go through. So now we can order these numbers. And another question is, what's the highest number we could have? So where would be the end? Even though you might be in elementary, you really are talking about the domain. What is the smallest number? What is the largest number? Where are we going from here? Okay, so that's kind of a fun question to do. What would it be if we had 10 times the random number? Okay, so you could do different things like that. So let me go on here, the number line. So another activity, and in the handout, hopefully in the PDF that you had, we have an activity called Go to Your Corner. I'm going to show you the PDF so you can see it. And Go to Your Corner, basically, the teacher, myself, labels each corner. So corner A has 0.0 to 0.249. Corner B has 0.25 to 0.499, and so on, C and D. So we have 4 corners of the room, and I have a little sign posted all there. And what they do is they go through and they find a random number again, and now you go to your corner. Okay, where are you? So pick another random number, go to your corner again. Where do you go? Go to your corner. And so they're using those to really look at numbers between. Okay, where is 0.61? This is a hard one because it's only 2 decimals. They might get confused there. Where is 0.61? Do I have to go to corner A? Do I have to go to corner B? So they're really thinking about comparing their number to what this corner is. And again, if you don't want to use decimals, you can change it. You can have 1,000 times random number, and then they can go to those corners. To turn this into a bigger exploration, what you might have the kids do is that, like in this, the worksheet says, guess how many of your classmates will end up in each corner when they create a random number. So they can guess, and it's fascinating to see what their guesses are. Okay, especially if you've already done this once, you can talk about it. But the whole idea of randomness is a tough idea to get across, especially in the younger cases. From the students I've worked with, which is many classrooms, they don't see that it should be 25% on each one if it's truly random. So this was kind of a fun STEM activity that a teacher was sharing with me to do. And so you can use this whole idea of the scientific method. How can we make a hypothesis? How can we test our hypothesis? What can we go do with that? So that's another nice exploration to do. And you will have this worksheet in the PDF. All right, so let's go on. Speaking of number lines, I really like this activity. We've done this activity in many different classes, including an AP Calculus class. We had fun with that one. But basically, we tell the kids that this number line is very dull. And it's boring. I just hate to have 0, 1, and 2, 3, 4, 5. So what I have the kids do is using your calculator, and usually I'll jigsaw it. So in your group 1, you get number 1, group 2, you have number 2, group 3, number 3. What they need to do is they need to use their calculator to rewrite the number using some different expression. So we don't just want 1. So for example, if we're doing 4, they could write 2 plus 2. Does that equal 4? Yes, that equals 4. How else could we do? Oh, we could do 2 times 2. Okay, that's another one. Oh, we could do 6 minus 2. That will give us 4. Okay, so we can do different expressions. If you're in a higher level class, or even if your kids are just going to explore, we could do 2 squared. Yes, we got 4. And so they have fun doing different ones. If you've done square roots, we can do square root of 16. Yes, we got 4. So they play with different representations. So you can imagine as we get older and higher level mathematics, the kids come up with some pretty creative expressions that will equal those. So this is another fun way to do it. You can have the groups find as many as they can that are equivalent to that number, or you can just have the kids figure out a representation for each one. And then it's fascinating to see how many different representations they come up with. Can we have 25? Can we have 30 different representations? And this whole idea of, yeah, we could have as many as we want. It's kind of an exciting notion that I don't always have to have the same answer that my teacher has. And that's really, I think, the essence of the Common Core, that we need our students to be thinkers and really think about the math. And perhaps my answer will be different than my teacher's. Perhaps the way I found my answer may be the same as the teacher's, but my method is totally different. So that's what's really exciting about the Common Core. All right, so let's go on. Okay, so knowing your place, this is another fun activity. And we're talking about place value here. So what I'd like you to do with your calculator, I know, okay, those of you that are still working on 1, 2, 3, 4, 5, you can take a pause now because we need to do a different one. I would like you to clear out your calculator by pressing AC, and I'd like you to enter 369 on your calculator. And of course, we get demo and press equals. So you have it set in your calculator. So now in one operation on your calculator, I would like you to remove number 6. So there's no longer be a number 6, it'll be a 0. So you're going to change 6 without changing the 3 or the 9. So we just want to change that 6 to a 0. How would you do that in one operation? And So we think about it, the kids explore, and then we find out, oh, well, we have to subtract 60. And in order to do that, you just hit the subtraction key and press equals. And now we have 309. Wow, how do we do that? And I know for those of you who are math teachers and have done this before, think, oh, that's super easy. But this whole concept of figuring out how to change this numeral, how to just change that 60, it's like, oh yeah, I'll just subtract the 6. No, because you're actually subtracting that 60. And so now, after we've done this, I forgot we can continue on. So now I would like you to change this number, 309. I would like you to change that 3 to a 5 in one operation again. How would you do that? So the kids play around with it and figure out, oh, I got it. So this time we're going to add 200, and then we get it. The exciting thing about this is the kids have their own calculator, their own personal space. If they get this wrong, let's say, for example, we had 309, and they get it wrong, okay, I'm going to add 20 this time. No one knows. It's their own personal space. They can try again. They can try again until they're successful. And it is so exciting to see in your class, as soon as they get it, they will turn around their calculator, show it to you like this, like this, like this. They have such a feel of empowerment because they can do it on their own. They figured it out. And so this PDF, I've included a worksheet for you to look at. Let's see, there's the instructions first. And then knowing your place. And so, for example, we have 27, and we want to change that number to 7. So what do? Oh, we subtract 20 from that one. So right here, you'd either write out subtract 20 or minus 20. 63, we want it to be 60. How would you write that? Oh, we're going to subtract the 3. So really giving them an idea, okay, we have to change it to that number, but also that explanation, that justification. We have to justify our solution to figure that out. In several classes, if you're doing decimals, you can do the same thing here. Really talking about that place decimal. You can just change these to decimals and figure out how to do that. So kind of a nice exploration of place value, how to do it. And then just not only with the calculator do you have your own personal space, but it's fun. It's something else to do. Because really in this activity, we're looking at place value. What is that place value? We're not so much worried about, oh, can they add 2-digit numbers? Can they add a 3-digit and 2-digit numbers? We want to make sure that they have the knowledge of that place value. So let's go on here. Oh, geez. Okay. Let's go on. So knowing your place, we have that. Now, let's talk about cookies. That's one of my favorite things to do. Cookies. I love chocolate chip cookies. Those are my favorite thing. If anybody knows, especially warm out of the oven. And what I want is, oh, let me show this to you. That's PowerPoint. Okay, if we can. Is it going to go? Okay. So we have some cookies on the counter, and Mom said she'll share with you. Okay? So we're going to share. So which shared portion will you accept? If your mom comes up and says, okay, you get that part of the cookie, are you going to agree? Yeah, sure, we'll agree. That looks about half. Yeah, I'll agree. What about this? Is that okay? Are you going to share? Is that okay here? Yes, that's okay. That's more than half. I'll take that. Will you accept this part if your mom's offering that? No. And the kids are like, no way, I'm not. Even teachers, when I'm working with teachers, say this. No, I don't want it. Why not? Because it's less than half. You can't do it. That's not fair. So if I'm going to share, if you're going to share with me, I want at least half, or more than a half would be okay too. And I know my kids are just the same. I'm the same way. Come on, I want more than half. So I want at least a half, please. Okay, let's make sure. So this is the activity we're going to do. And what we're going to do is on our calculators, we are going to use random numbers. And so let me exit out of this. So now we need to set this up a little differently. So now go to Setup on your calculator. And this time we're going to use Math the math setup, number 1. And now when we hit random number, something magical happens. It's in math type. It's showing us actually what it equals. And some of you might be freaking out. Oh my gosh, 223 over 250. That's not, we don't need to do fractions that big. But you students really need to have a sense on where this number is. So this activity is, okay, are we at least a half or are we more than a half? So on this one, oh, yeah, we're totally more than a half. We're getting really close to that 250. So I will totally accept this cookie. And to check on the calculator, if you press the F to D button, we get 0.892. Yes, see, I'm much closer than 1. How do you know that? Well, I'm bigger than 0.5. And so this activity, we have random fractions. I have this in here, tell you exactly how to set it up. So you can set up using the math and pressing that fraction to decimal. Now I have in the PDF, I have a worksheet for you. Which fractions are, no, I'm not accepting that cookie. It's less than a half. Or yes, it's at least a half. I'm accepting that cookie. So and I tell the kids probably do 10, 15, whatever cookies. Okay, so we have 277 over 1,000. Ooh, is that less than 100, a half, or is it at least a half? What is this? How does that work? Well, and we want our kids to start thinking about, okay, half would be at 500. 277 is less than, so no, I am not accepting this cookie. And the kids can check F to D. It's 0.277, so yes, it is. And then we can continue to do this. Oh, it's really close. And really the number sense, if you've read articles by Lyon and different people are really talking about, our kids need that sense of, is it close to 0? Is it close to 1? Is it close to a half? Those benchmarks, where are they on the number line? Where is that number spectrum? And 3 over 200, oh, it's way less. There's no way I'm accepting that cookie. So just an idea of this number sense. Where is it? If you see huge fractions like this, don't be freaked out about it. It'll give us an idea of where we are on the number line. So what are some other ideas for random fractions? You can line it up with fractions and have them compare with the decimals talking to each other. You can do fraction war, whose is bigger, if you ever get the same kind of thing. Other ideas, there's lots of different things you can do with random fractions. I probably wouldn't have them adding these fractions. The denominators are usually way too large. That would just be mean to my students. But there is another way. If you wanted to do some kind of adding, subtracting, what you could use is, there's another yellow option right above random number, is shift. If we hit the shift button, the little S comes up here. Shift ran integer. That will give us an integer value. And so if you want to have them set up their own fractions, we could say, okay, I want a random integer. Let's do 1. From 1, and there's a comma right above this pi. So shift and then that comma. Between 1 and 9, you can end parentheses if you want or not. So these will give random integers between 1 and 9. You can see we can press it several times. And now you can have them, okay, first number is your numerator, second number is your denominator. This is going to be an easy one. Plus, there's your numerator, there's your denominator, or you can have them place it as 2 different ones and now add those 2 fractions together. So it's a nice way for the kids to make up their own. This is more of just practice kind of skills. So there's different ways to do that. All right. And then, of course, you can do random integers. If you don't want to roll dice, if you're doing some simulation and you don't want that crazy noise in your classroom of kids rolling dice everywhere, you can always say, okay, I'm going to do a random integer. And then we can edit this. A die has 1 to 6 options. And so now this is just like rolling a die. So this is another nice random feature on there. All right, so, and then what can you do with random integers? You can, if for those of you that are doing rational numbers, you can actually have it do some negative numbers. So we can do it from -9, oops, take off that 1, to +9. And so now you have random integers. So you can actually say, okay, -6 plus 1, a -2 minus a -3. So you can have several problems there to do that. And same thing with war. You could do some integer war whose number is bigger, whose number is smaller. All right. So continuing your idea of fractions, and I've included this activity also in the PDF, is we have a recipe, rise and shine oatmeal cake, but those of you that cook know recipes get really dirty and you've got milk spots and sugar spots and everything. And so unfortunately, these are all blanked out. So we need to figure out what actually were those numbers. And I put this little picture over here because I have fraction circles and I love using these fraction circles because not only are there fractions, but on the back there's decimals. But we can also use this with our calculator. For measuring, when we're doing measurement, we have measurement cups, half, a third, quarter. I think we even have an eighth cup. And then you have teaspoons, half teaspoons, quarter teaspoons. So we know that we have a limited amount of options here. So this 0.7 something cups of milk needs to be some fraction of the milk. And so we can figure out, well, 0.7, let's see what a half cup is. And so what they can do is they can enter, let me show you how to do this. If you use the fraction key, which is this first green one here, let's say we have 1/2, so a 1/2 cup. If we press equals and then the F to D button, it will tell us, oh, that's 0.5. That can't be right. Well, could we do 2/3 of a cup? Let's try that one. So we're going to enter 2/3. Let's see what that is. 2/3 is about 0.667. Would that be anywhere here? Oh, maybe this would be here. So 0.67 if we round it. Okay, so we know that we need 2/3 of a cup of sugar. Okay, we got that one. Yes. Let's figure it out. We're still trying to figure out that 0.7. Let's see if we can do maybe 3/4. So they go and they play around and see what that connection is. F to D. Yes, 0.75. So I know that would be that. So they're really exploring what are the decimal equivalents. Some of these were actually tough for me because I don't memorize all of them. This 0.6 what? 5. What is that of a stick of margarine? How far is that? And so that was a tough one. So that'll be a challenge for you to try later. So for those of you that are in a workshop setting, pause it and have the teachers figure this out. But a nice before you use the calculators is to use some kind of fraction circles or fraction tiles that actually have the decimals on the back and the fraction on the front. So they can really manipulate those fractions and what they look like. Another fun game that I included in your packet is And the Winner Is. And basically the goal for this is to get the highest sum. Before you use fraction tiles here or the calculator here, what we want is player 1 has to circle 2 numbers on here that they believe will have the highest sum. But this is in the long run. So for example, when the students might pick 9 5/8 and 10 1/5. Okay, so those are the 2 they circle. Then they go to the calculator and we can use this, since it's a mixed number, we can use this 9 and you use the little arrows to pop over if those of you have used equation editor or math type. So we have 9 5/8, arrow over so you can see the cursor is between the 2, plus, and we have our mixed number 10 1/5. And then we can add those 2 together. So my total, and we need to change this back. Let's see. I'm going to have my setup. My setup's different. And we'll change the setup in a second. It will give us this or, I just need to put a setup. Or notice here, we can have it in 2 different modes. So it will give us a mixed number in 5, or it will give us an improper fraction in 6. I'm going to change it under my setup to 5. So now, let's go back up and change it. Oh, what am I doing wrong here? Simplify. Number 7, auto. And there we go. So I had it on the simplify it needs to be. So now we have 19 33 over 40. So that's the first person's total so far. The next person will pick 2 numbers. add them together, and now they have a running total. So now you pick another number. Okay, those 4 are already used, so you need a different one. So now I'm going to use 9 1/3. Okay, so now you don't have to rewrite it. You can just take answer plus 9 1/3. That probably wouldn't be left. 9 1/3. So you continue to keep that running total. Now, of course, you can have the kids do it by hand, but getting to denominators of 120, there's really no reason for you to do that with your students. Your students don't need to know how to add fractions with denominators that huge. However, by doing this, they're really using their powers of estimation. What do I think? Okay, so I want to add all the numbers with the largest number there before the largest mixed numbers first. And now we want to go down. Well, we're getting to 9/16 and 9/10. Which one's bigger? So which one do I want to pick? 8/11 and 9/10. Which one's bigger? Which one do I want to pick? So it's really giving the kids the ability to estimate how close is this. And that goes back to ordering up our fractions and really using the F to D button to really think about what those decimals mean, how big are they, and then just converting, doing it by hand, converting it to decimal and back to a fraction. So that's another nice activity to use. All right. Greatest common factor. I know lots of teachers teach that every year. And so we found, and this is kind of a neat activity, it says that students discover a way to find the greatest common factor using this simplify key. Okay, so basically what we want to do is we want to find out what the greatest common factor between 12 and 72 is. Did I show you the no? So before we do this, let's change our setup on our calculator so hit setup. Number 7 is simplify, and I want to change it to manual. Okay, so number 2. So now we have manual simplify. I'm going to push AC. So I want to find the greatest common factor between 12 and 72. And to do this, let's start with a fraction. Because often finding your greatest common factor is really useful when we're trying to reduce fractions. So let's enter this fraction, 12 over 72. And then press the equal sign. What the calculator says, it says, hey buddy, this little down arrow means it can simplify further. So you don't want to leave it. It's not simplified yet. So there's this button called simp. It's the green one over here, the 5th green one over. If you press simp, it'll say, okay, calculator, simplify this for us for a little bit. Okay, now I usually stop and say, okay, in your groups or with your partners, what did the calculator just do? What does that F mean? What does that arrow down mean? Where did they get 6 over 36? We had 12 over 72. What just happened? So they talk in their groups. Okay. And what they hopefully will share is that, okay, F, the 2, is what they divided by. 12 divided by 2 is 6, and they divided both of them by 2. 72 divided by 36. But why is it F? Why is it called F? That's a factor. Okay, yeah. But what does this little down arrow mean? Oh, it means it can go down further. Well, what can it go down by? Well, let's see what it'll do. You can have the kids predict, and then we simplify again. Oh, it went down by 2 again. Okay, so what happened? Some of the kids may have predicted 3. What? Why didn't it do 3? Well, what's going to be the next one? So you talk about what is the F? What does that down arrow mean? Oh, it can do some more. So what's it going to do this time? And that's where the kids can predict. Okay, we're going to simplify again. Yes, there's my 3. What does it mean? There's no down arrow. Oh, that's as simplified as it can go. So what does this have to do with greatest common factor? Do we need to do this every time 3 steps? Have the calculator do it. Well, the first time the factor was 2. The second time the factor was 2. And the last time the factor was 3. Does this ring a bell with anybody? This prime factorization we're going through and we're figuring that out. So to find that greatest common factor is just multiplying all those together. But that's something to really explore with the kids. Well, how could we? If we started with 12 over 72, their goal is really to find out what is that greatest common factor between those two. So we don't have to do this every time. We don't have to simplify. And so here's another example, which you can pause if you want to do this. between 45 and 60. Okay, what are some factors and what is the greatest common factor? And so using that simplify button, you can go through and do that. So that's another example. And there's several examples in the PDF. One of my favorite activities is the Great Pizza Caper. And you can look at this in my workshop. Of course, I had you all go through and do this. But Max ordered 4 pizzas is the first scenario. And his brother ate 2/3 of one of them. How many friends can Max invite to share the remaining pizza if each friend eats 1/3 of a pizza? So, of course, I have the kids go and do this. And they usually are drawing diagrams, figuring out what's going on. And so I ask them to draw a diagram and also write out the mathematics. And then how could you do it on the calculator? So we're just going to go right to the calculator. However, I'd like you to do the others too. So we start, I'm going to clear, so we have a clear screen. Max ordered 4 pizzas. Okay, so we have 4. Then what happened? Oh, his brother ate 2/3 of one of them. So how much is left? How can we figure out how much pizza is left? So we can subtract off 2/3 because he just ate 2/3 of one pizza. So we have 1/10 of a pizza left. Ew, what does that mean? So we can change it back and forth. Oh yeah, I'm on auto manual simplify. So we can sit there. We have 1/10 left. Well, how many friends can Max invite to share the remaining pizza with if the friend eats 1/3 of the pizza? Well, leaving it like this, we have 1/10 of a pizza left. So how many thirds are there? There are 10. So we have 10. Or on your calculator, we want to divide it by 1/3 because we want to know how many groups of 1/3 can we have. And we see that there's 30 out of it. Oh, we have it on. We can change that to simplify, auto simplify. So we see that it's actually, you can split it with 10 people. But let's redo that again and change our setup. So we have simplify is auto. So we'll automatically simplify it for us because we don't always want our answer is 10/1. So now let's start with that first one. We have 4, and we're going to subtract off 2/3. So we have 3 pizzas and 1/3 left. And now how many thirds do I have? You're going to divide by 1/3. Ah, look at that. So when you get this weird, thank you for getting this error because I know some of you will. When you get a compound fraction like this, which most of you who are teaching in elementary probably won't do compound fractions in your class, you just hit delete and it will go back. And you can continue hitting delete and it will delete the previous expression. So all is not lost. So now I just need one fraction divided by 1/3. And now we have 10 people. So, and then there's 2 other scenarios, and then I have the kids make up their own scenarios. Okay, let's think about that party. Let's think about our class. How many pizzas would we need? What's going to happen if Ms. Nomo eats 2.5 pizzas before you even get to see it? How many people would get, 1/3 piece of the pizza? And then the kids will say, 1/3 of the pizza? You can't do that. They cut it into 8 slices. Well, that's another question. How many slices would they have to cut it into if you wanted 1/3 of a pizza? So there's always questions. Whenever students bring up questions, encourage that and then send them questions back. Okay, but we can't. But what if, how, why? All those questions are great questioning strategies. Okay, the last activity I wanted to share quickly is this is a fun one where you have $1 million, and Bernicia, Jasmine, and Marcus dream about this. And this is an activity from our fostering series, the Casio's Fostering Middle School Math, written by Dr. Robert Horton from Clemson University, and this is one of his activities. And so you have $1 million, and Bernicia, Jasmine, and Marcus dream about it, but they say, wait a second! If we had $1 million, so I'm going to do this on the calculator here. Did I get it right? If I have $1 million and I divide it up for 3, what's going to happen? What? Someone's going to get more than me. Who gets more dollars? That's not fair. Well, and so you ask the kids, what if there were 2? If there were only 2 people that had to split $1 million, would that be fair? Oh, yeah, because they'd each get 500,000. What about 4 people? Could you divide that up? Yeah, we could totally divide that up. And they can explore. So you could just give them several numbers. Which ones would be fair? Which ones would not be fair? Why do we do this? We just want to explore. Well, what the activity goes through into is we can see this. Okay, for 2 employees was the activity he did, or if we want to split the winnings is 500,000. Yes, it's equal. 3 people, no, it's not equal. 4, yes. Well, have we seen these numbers before? The 3333333, the 1.6, the 1666667. Ooh, these look familiar. What about 7? What is the common thing? How will we know if it can split into equal amounts? And so, of course, you're gonna do some discussion with this. If we think about the prime factors of all of these, wait, when the prime factor was a 2, yes, it did equal amounts. When it was 3, no, it didn't. When it was 2, yes. When it was 5, what? When it was 5, yes, it did. So we look at these patterns, and what happens is if you look at those unit fractions and compare it to the decimal form, and the whole activity goes through this, you could talk about what terminates, what doesn't. And this is a standard, actually, I believe in 6th grade, Common Core standard. Which decimals terminate, which ones repeat, and why. And so you can actually use the calculator to go through this and talk about why is it terminating, why is it not terminating, and it really has to do with those factors. Which are prime factors that go through and divide that. So making some conjectures and then proving your conjectures. So that pretty much concludes most of the items we went through in the workshop that we did. And so feel free at any time to peruse Casio Education website, because there's lots of resources on there, many more activities for elementary, especially with this calculator. It's called the FX55 Plus. And there's lots of ways to explore with the calculator and give the kids ownership of their own learning. So thank you for joining us. My email is there. If you ever want to email, feel free. Thank you very much.